Control charts. Last bit we've got to do is a fairly nice topic. Right, here's a question to wake you up. How much rodent hair are you allowing in your food? Now, rats are in factories, so they can get into machineries. So there is a little bit. Now, this is the American government, not us. And they say you're allowed 1 rodent hair in every 100 grams of food. Okay. Now, if we're a food manufacturer, we need to somehow monitor this. Now, I've done a bit of maths for you. Okay. Now, what we want to aim for is half a hair for every 100 grams. Okay, that's all like our mean or average, and we want a standard deviation of a quarter. Okay, this means that if I do hit 1 hair, yeah, which is actually going to be 2 standard deviations away from my mean, yeah, then I'd have to look at it and like retest, yeah. But if I'm 3 standard deviations away from the mean, yeah, which is actually going to be 1.25, yeah, then that means that I'll need to like close the factory down or doing something else. Now to do this as an actual like chart, I get my normal curve and I sort of put it on its side. Just be a little bit careful because my graph here is reversely numbered. It shouldn't be. Yeah, but it's just for the sake of explanation. Yeah. And I'll put some lines in. First line is the one that I want. Okay. Then I've got my upper and my lower target. Okay. Now these are like warning though, really. So if they hit this number, they go above it. That's a warning. So we've got to look into this, try and see if we can work out what's going on, or maybe there's a rat infestation or something. Okay. And then we've got to put the ones which are 3 standard deviations. Now, if they go above or below these lines, yeah, then that's an issue. That's the one you have to like close the factory down essentially. Okay. Now, if I put in a bit of data, okay, these are fine. Even though there's rat hair in it, that's what the government allows. So that's cool. That's fine. Now this one here, you might look at it, you think, oh, this is actually above my warning level. But what that means is you just got to pay a little bit of attention to the machine. Normally, you just do another sample on the same day to see what happens, or a sample on the next day. All of these, the rest of them are fine. Now that one there, that's an issue. So this one here means there's more than 1.25 of a rat hair in the machine. So that means that we have to close that machine down, or maybe even close the factory down. Okay. Now it's really important that my first warning levels are 2 standard deviations away from the mean, and my final one is 3 standard deviations of the mean. Okay. Unless it's given otherwise, these are the ones that we use. Okay. So here's a question for you. A machine makes squares to be 4 centimeters. A sample is taken and the mean is 4, and the standard deviation is 0.25. Okay. Assume the data is normally distributed. Right, let's say the sample is taken each day. Work out the average and draw a control table for the data below. So essentially I want you to make an average for each day. I want you to draw a, call it a time series graph without joining up the dots, or a scatter graph. Okay. I then want you to indicate the limits. Just remember, like the first limits are 2 standard deviations away from the mean, so you need to work that out. My next one's 3 standard deviations away from the mean. And then comment on any of your findings. Go do it. Pause the video if you need to. Right, I've worked out the average. Add them up, divide them by 4. Okay, plot them on your scatter graph. There's nothing really I need to talk to you about that, apart from label the axes, which is not what you mean. Right, all up my upper warnings and my lower warnings. So I know my standard deviation is 0.25. 2 above it would be 0.5, so 4 plus 0.5, and 4 minus 0.5. 3 standard deviation is going to be 0.75, so I add it and take it away. Okay, so these 2 here, they're going to be my warning levels. Okay, and I'll put in my limit levels. Now, if you look, all of these are within my warnings, apart from that one there. So I'd say on day 4, I got an average, but I just retook another one, and it's fine. Same as day 8, I took average. Yeah, that's fine. So day 7, and then I did it again, and that's in between levels. So I'd say there's a few issues, but nothing really for me to reset the machine or control the machine. Okay, last question I'm going to do. A company selling packets of sweets. They aim to have a daily average of 135 sweets in each packet, with a standard deviation of 2. Samples taken every day. Draw a control graph of the samples below. Add action limits and warning limits and comment on the graph. Pause the video, do it please. Okay, let's talk you through it. I've worked out the average, so I'm adding them up to 1 by 4. Okay. I've plotted it. Look at the bottom, I've actually used letters, which is sort of an unusual thing to have on the bottom, but the letters do actually represent times, because each letter does represent a day. Okay, this is a lot more scattery than the last one. Make sure the titles are in there and everything's labelled up. Okay, I've worked out my limits, and because my standard deviation is 2, my first warning's got to be 2 above and 2 below, so 4 above and 4 below, and my actual warning's got to be 6 above and 6 below. Okay. Pull the lines in, okay, and then you can see the first day you can say that there's a warning. Okay, and did again, actually B is actually on the line, should have used a different colour. That's fine. D, there's another warning. Then it came back to normal. Then F, we should have stopped the machine then. And this repeated with H. H, we definitely should have stopped the machine. So if something's happening in the machine, we need to reset it or do something else to work it. Okay, good. I hope you enjoyed that. Do the textbook work.